Hello, welcome to Simplified SAS classes. This is second class for cluster analysis. In the first class we have covered hierarchical clustering. In the second class we are covering non-hierarchical clustering, which is also known as k-means clustering. So let's start the class. Non-hierarchical clustering, this is also known as k-means clustering. K in k-means signifies number of clusters. So it means how many clusters we want to make while we run the fast plus procedure. Proc fast plus basically is the SAS procedure is used while we do non-hierarchical clustering in SAS. Alright, this is used while the number of observations is quite large. So as we discussed in first class that up to 100 observations or say 150 or 200 observations we can use hierarchical clustering. However, if the data is too large, real industry data in millions, in thousands, we use k-means clustering or non-hierarchical clustering. Alright, as a best practice, or it's a matter of choice that you can go two-step process for clustering. Per se, you have 1 lakh observations data with you. What you do, you first use k-means clustering to come up with 100 clusters. Right now you have a data set of 100 observations, right, that those 100 clusters which you have come up. Now you use hierarchical clustering further to make subsets or clusters and finally come upon your final clusters. So it's definitely a matter of choice. There are two basic differences. The first basic difference between hierarchical and non-hierarchical clustering is number of observations. Less number of observations, go for hierarchical one. More number of observations, go for non-hierarchical one. The second difference is that in non-hierarchical clustering you tell that how many clusters I want to make first. However, in hierarchical, it automatically gives you result at each possible cluster 2, 3, 4, as I have discussed in class 1. That then on basis of CCC or pseudo F or pseudo T or RMS STD value, you then decide how many clusters we should make. Here we initially tell how many clusters we want to make. It's a different thing that later on in non-hierarchical clustering too, we decide how many optimal number of clusters should be made. Now let's understand the algorithm behind it. So first let me tell you theoretically and then will demonstrate you visually. First, all the data is broken down into k groups randomly. Now for all groups a centroid point is calculated. Once these centroid points are calculated, which are also called seeds, all the observations are again assigned to the nearest centroid based on the distance. Once this assignment is complete, with new clusters formed, a new centroid is calculated. These iterations go on till the time assignment of observations stop changing and we say that our model has converged. Now let me show you how it happens. Let's say this is number of, these are observations lying in XY scale. Now let's say in starting we we make 3 clusters. Let's say we give 3 as our k, fine, and it randomly picks these observations into one cluster, these observations into second cluster, and these observations into third cluster. Ideally these two observations should be in the cluster which are same as this. However, as it takes it purely random fashion, so it doesn't know how to assign in the first time. Now once these clusters are complete, what it does, it again calculates the centroids. Now let's say a new derived centroid for this cluster is this one. For this cluster along with these two observation is this one. This one, let's say distance is this one and distance is this one. Now we see that the distance of these observation is now with this cluster, right? So the new cluster would be like this one. Again, after assigning the cluster, new centroids would be calculated. It would be now somewhere here, somewhere here, and somewhere here. Again distances would be calculated, and this iteration go on till the time assignment of the observation changes, right? So now as you can see, if the centroids move to these points, there won't be any change of the assignment. So the model has done.